All right, this is like take 6. I keep on trying to do too much in the video and it keeps going over. So I guess I'm going to do the next example on its own. Here we go. State the degree of each function, then describe the end behavior and name the y-intercept. I think you guys can do this. It's really not a hard problem to do. All you have to do is count the degrees. We got a 3 plus 1, so that makes the degree 4. Because it's an even degree, we know the end behavior is up, up, unless it's preceded by a negative, which it's not. To find the y-intercept, we plug in 0 for x, so we get 2 cubed minus 3 times negative 3 rather, which is 8 times negative 3 is negative 24, which tells us the graph of this will look kind of, sorry about my messiness, crosses somewhere down at negative 24. Um, it has, let's see, a root at negative 2. It's got a root at 3. This behavior is up, up. So let me go, um, let me pick a different color pen. So its behavior is up, up. So it starts up here. The multiplicity of 3 is going to give it a little, um, sorry about this, not very neat here, a little flattening out there. Kind of like your y equals x cubed function. It's going to go down here. And because I've done this before, I know it goes deeper than that. It keeps going down. And somewhere down there it's going to turn around and it's going to come back up and it's going to hit 3 and go through smoothly. How do I know? Because the multiplicity is 1. Do we need more points than these 3? Not really. That's sufficient. Okay. You can get more. Like I said, I plugged in a 1 here so that I would know if it's continuing down or if it's on its way up when it crosses through here. But that's really up to you. When you plug in a 1, you get like negative 50, what, 54, negative 54. So anyways, that's that. For g of x, you can go back to black here. Um, First thing is do the degree. So we have 2. This is a quadratic that's irreducible because it has complex factors, but there's still a degree of 2 there. So 2 plus 2, 4, plus 1 is 5. So the degree is, degree, extra letter there, is 5. And because it's 5, we know it's normally down, up, but because there's a negative out in front here, we're going to say it's up, down. And so I'm going to have something that looks like this. The y-intercept we find at g of 0, which when you calculate it, go ahead and do that. Press pause. Okay. You should get 18, positive 18. 0 plus 1, 1 squared is 1, plus 0 plus 33, 0 plus that, negative 6. So 3 times negative 6, negative 18, but double negative makes it positive. So at 0, 18, it crosses. Also at negative 1, crosses at 1, 2, 3, 4, 5, 6. I shouldn't say it crosses, it has a 0 there. 1, 2, 3, 4, 5, 6. So these are the zeros. Whether it crosses or not actually depends on the multiplicity. And here the multiplicity is 2. It started up, it has a 2 here, so it's going to come, started up, it's going to come down, it's going to hit, it's going to go up, and at some point it's going to hit this. Now the question is what happens after that? We don't really know to be certain, but we can kind of infer, because it's got a complex root that some of the bumps are up top. So I'm going to go with a pen like this. I'm just going to go dot dot. I think some of that action kind of happens up there before it comes back down. And when it comes back down, it comes back down and goes through smoothly at 6. Boom, I missed. So there, I'll make it bigger. If you don't hit your target, move it, right? Okay, so that's kind of what happens up there. I can't be totally certain of that, and neither can you, because we haven't tested it and proven it, and we can't really in this class. That's why math doesn't end here. in algebra, college algebra, it goes on. There's pre-calc, there's calculus, and that's where you learn to find those local maximums and minimums so you can figure out what else is going on in this picture. But there you go. So that's that one. Ooh, much better time. I'm going to continue to the next page. This page is matching. Um, the following functions, they all have zeros at -2, -1, and 1. Why? Because we have x plus 2, x plus 1, and x minus 1 are factors in all of these functions. How they differ, though, is in their multiplicity. So where this one has a multiplicity of 1 for this factor, this one has 2, this one has 1, this one has 2. So there's some differences in the multiplicity, and as such, there's also some differences in the degree, which will affect if it's up, or down, down, or down, down. Um, these relate to problems 37 through 42 that I assigned to homework, as homework to everyone. So check those out. Anyways, if you want to give it a go, give it a go. Process of elimination. I'll do the first one here, and you can pause if you think you can do it on your own, or you can listen to this and then pause after I do this one. The first thing I'm looking at is this multiplicity of 1 that's on the factor x plus 2. Because x plus 2 equals 0 when x equals -2, I know the corresponding root is -2. And what does it do at -2? This function a, it actually crosses through smoothly because the multiplicity is a 1. So this, here's -2. This root does not cross through smoothly, so it is not a. This line does not cross through smoothly at -2, so it's not a either. This one does cross through smoothly, so it could be a. And this one too could be a. So your next thing is to look at the next factor or count the multiplicities. Ready? 1, 2, 3, 4, 5, 6. So this is even. It should have up behavior. Up, down, up. So that makes this one definitely a. We can further confirm that by looking at the second factor, which has a multiplicity of 2, which implies it should bounce off at -1, which it does. Furthermore, it has a multiplicity of 3 for x minus 1, which means at 1 it should have a little chicane, and it does. So there you go. Just using the multiplicities and the degrees, we have figured out that this is a. Do the same thing on these other ones. Press pause now if you want, or you can listen to my explanation. In 5, 4, 3, 2, 1. Okay, this one's B, because when you look at B, it's a smooth crossing at -2. When you look also, the degree is 1, 2, 5, okay? And that means it should be down, up, and it is. So that's further confirmation. We have down, we have up, okay? But as final confirmation, we can look at these last two factors. At -1, it should go through smoothly through. It does. And at +1, it should have a little bend, and it does, because it flattens out at 0. Up here, this one, the next one you should have found was C, is this one over here. If you thought that this one was C, then you might have been misled because it does bounce off at 2, but look at the second one. It should also bounce off at 1, and because the multiplicities add up to 7, we have something that's odd, so it can't be up. This one's definitely C, and working through it, this one's definitely D. All right, C at -2 bounces off, at -1 bounces off, at 1 it's got a little bend thing. Sorry, not a jump. All right, and that one's D. Let me save that, and we'll continue in a moment.